This is Edexcel paper C2, May 2015, part 2. Right, we have a fairly straightforward integration question, alright. Should be fairly straightforward, as I say. First of all, we've got to get it into a form so we can integrate it easily. So actually what I'm going to be integrating is this 10x to the 3 over 2 minus 20x, sorry, just minus 20x, not x squared. So there you go. When I integrate that, I should end up with 4x to the power 5 over 2 minus 10x squared. You can put the plus c on, but the plus c is pretty irrelevant actually, because when you start substituting numbers in, and it sort of drops out, doesn't it? It cancels itself out. Now, when I'm getting to doing the curve, because I've got a part under the x-axis or below the x-axis, I've got to integrate. I've got to swap those bits in from 0 to 4 first. Alright, and then I add on the part above the x-axis. So we get this and this. So I've got to add on from 4 to 9. Alright, and I'll give you the answer to that. The answer is 226, but you're going to have to show the workings. Okay, we've got a little log question here. Should be fairly straightforward. Here we go. So the first bit is fairly straightforward if you can remember how to convert into logs. Alright, log 8 equals log 24. Alright, rearrange, solve to find x. That should be fairly straightforward. The second one's a little bit nastier. I'm going to convert everything into log 2 first of all. So log 2 of, now these are your rules of logs that you should know. So the 11y minus 3 is on top of the fraction. When we have a minus, there's the minus there. Okay, that means we divide. So I'm dividing by 3, okay, first of all, and I'm dividing by 2 log y, which we write as a y squared. Right, the 1 I convert into log 2. Log 2 of 2 is 1. Alright, so there you go. Now, once I've got that bit, I can then do this. And I get over 3y squared equals 1. Rearrange, solve, factorise, and all that sort of stuff, and jobs are good. Right, I've got a trigonometric question here. The rule I'm going to use for part 1, so for this part, is I'm going to be using that sine theta over cos theta equals tan theta. Alright, so that's the first thing, and I've done it all over here because I'm going to need some space for the second part. Alright, so if I divide everything in here by, I'm going to divide everything by cos theta, 3 theta. Alright, I'm going to end up with sine 3 theta over cos 3 theta minus root 3 equals 0. That I can rearrange to get tan of 3 theta equals root 3. Alright, we then get 3 theta equals, and you should know that tan of root 3, so shift tan of root 3 is pi over 3 or 60. Alright, and keep going. Alright, so what's theta? Theta's pi over 9. Now for part 2, that's I'm going to be using the fact that sine squared x plus cos squared x equals 1. Right, so how I plug that in initially is I do 1 minus cos squared theta, because I can't solve anything until all the trigonometrical bits are the same thing. Alright, equals 4 minus k. Alright, now multiply that out and simplify and stuff. Alright, and I should end up with this cos of x equals 1/8. Yeah, use the quadratic formula. It's a little bit nasty, this. Well, it looks nasty, actually. It's not too bad, actually. But it barks worse than its bite, I think, is what we could say. It equals k over 4. There we go. Once you've got that, so that's for part A. Part B, all right, all you do is I think you've got a value, hang on, you've got a value of k equals to 3, so you're actually solving this equation, which is 1/8 plus or minus square root of 1/64 plus 3/4. Now you're going to end up with 3 answers, because I'll tell you what the answers are. Cos of x equals 1 and minus 3/4. I'll let you do all the workings for that. But basically, this gives you one angle, and this gives you 2 angles. So you should end up with 3 solutions in total. Right, solid glass cylinder. I mean, you can read it for yourself. But basically, all right, the surface area is going to be equal to, all right, 2 pi r squared plus times 3, because it costs £3 per square centimetre, plus 2 times pi times r times h times 2, because it's £2 per square centimetre around the curved bit. Now we don't know h, so if we know the volume of a cylinder is pi r squared h, so pi r squared h, and we know that's equal to 75 pi. Right, so let's do some cancelling, that and that. I now know that h therefore is going to be equal to 75 over r squared. Alright, and if I put that into, well, what colour shall I use? Blue. If I put that in for that, I should end up with what they give me here eventually. Okay, so that's what you've got to do, substituting. Now for part B, it says use calculus to find the minimum cost of polishing. Now we know that C equals 6 pi r squared plus 300 pi r to the minus 1. What you're finding is this C d r. Alright, so you differentiate with respect to r, and I'll tell you now that we get this sort of thing. We get r equals 2.92. I will tell you that answer, but you've got to work out how they come to it. Alright, and once you've got that, you should be able to find C. So the large C, that is, not part C. Now justify your answer that you've obtained B as a minimum. So you need to do d2c dr squared. All right, put in that value of r, and you find that it should be greater than 0 to offer you a minimum.